The Fermi paradox. If there are alien civilizations out there, when we look up at the night sky, why don't we see them? Where is everybody?
Where the heck are they?
Where is everybody? Oops, wrong one. Where is everybody? So how are you doing, Gern?
I'm well, Pat. Here, let's see if this can you see that? There we go.
I do. Very
Okay.
good. Thank you for the audio visuals there.
These are my notes.
Be more sophisticated than this at this point, but obviously I am not. So I'm simultaneously casting this on YouTube. So I'm going to see if this works. Go live. So anyway, yeah, we're going to talk about the Fermi paradox, and Gern's a long time repeat. I actually found an old podcast of ours, a show that we did, and good. And it's appropriate because it was about the Return of the Jedi, and it's going to be 40 years old next Thursday. How about that? The release, anyway. Yeah.
It's impossible. Right? It's impossible. It can't be.
So glad that I did this. And actually, Tara and I saw the Empire Strikes Back on the big screen last couple Thursdays ago, and I actually got dubbed a Jedi Knight by a reverend in the Jedi Order.
Well, there's nothing like seeing a movie on the big screen. It's something that I hardly ever do anymore, and I think a lot of us are in the same boat. Post-pandemic, we stopped going, or during the pandemic, we stopped going, and home theater systems have gotten so good that for the lazy among us, it's really kind of keeps you at home a lot. But boy,
I mean, you end up paying all this money for these streaming services. You're kind of like, why should I go to a movie, right? But every once in a while, it's an event, so it was fun. And when the guy said like he could dub me a Jedi Knight, I don't think it took a tenth of a second before I said, yes, please. I've been wanting to do this my whole life. So that was fun. So if you want to see the video, it's on my channel. Go for it.
It's not a life for everybody.
So the Fermi paradox, we're going to get to that. But first, we're going to get to know each other. We know each other really well, but the audience may have this might be the first video they've watched of us. So we're going to do the lightning round, which is I ask like 5 questions and we answer as quickly as possible. So what is obviously the last book we read is probably the Fermi paradox book, but what's the last movie you saw in the screen, on big screen or not? Go.
Oh, holy cow. Boy, that's actually a tough one. I don't watch a lot of movies.
Television show?
A television show, yeah.
You don't have to be embarrassed.
Gardener's World.
I don't know that one.
it's a British show. I subscribe to a British streaming service, and it's on every week at Friday at 9 o'clock. It's been on since 1966.
This tells you this. I did not know this about you. How about that?
It's a staple in Britain, and we discovered it a few years ago, and that's where my life is now.
That's fantastic. Great. So I watched Lower Decks, and what's your latest superpower? This man, by the way, is an amazing caricature artist. Did the 31 in 31 on days in January. He's been doing caricatures, unbelievable. But I know you're a superpower there. But what's your latest superpower? Have you acquired any since we've last spoken?
No, but I was thinking yesterday about what if alternate versions of some famous superheroes. What if Bruce Banner, instead of becoming super powerful, instead became really small when he got angry and just became the incredible, tiny, angry man?
Like Ant-Man.
Not quite that small, but maybe like 3 feet, 2.5 feet tall. Just furiously angry and small.
That is hilarious. That is hilarious. I love it.
I don't think he ever would have been accepted on the Avengers if that had happened.
I was just talking to somebody about, he met Walter Koenig, and he was apparently he's of short stature, as am I, and but he's apparently of pronounced short stature. But the man that I was talking to is blind. He went blind about 20 years ago. So he really can't see anything anymore. So he was at a Comic-Con or something. He was talking to this guy. He didn't know who the guy was. He was just talking to some guy. And then I'm like, how could you not know from his voice? He's like, I don't know. I was just talking to some guy. I didn't expect it to be Walter Koenig. But like my buddy walks up to me. We were talking for 10 minutes. I'm talking to this guy. And my buddy comes up and says, hey, what's going on, Phil? And Phil says, well, I'm just talking to him. I didn't get your name. What's your name? And his buddy says, I know who Walter Koenig is, He said it was the most awesome thing. It was just a couple guys talking, nothing.
Very nice.
No celebrity thing, just there, but I thought that was pretty cool. So, let's see, what else? Oh, well, we talked about this once before. Maybe your ideas changed. If you could have one ability tomorrow morning when you wake up that you don't have now, what would it be?
Wow. So the typical ones are flight, invisibility.
We can narrow it down to that. Would you rather have flight or invisibility?
Invisibility, I think.
Yeah, I like flight. I think I'd be too tempted to do nefarious activities with invisibility.
So flight's achievable through mechanical means.
That is true.
But invisibility is not. So.
Ooh, but there. Maybe I'm not allowed to talk about that.
Don't let any secrets out of the Matrix lab.
Shows where they have these like cameras on one side and then projectors on the other, and it's kind of like a ghillie suit. It's almost like that shimmering effect on Predator. And so I don't know if they've developed that any further than when I saw it 20 years ago. I suspect they have because I haven't seen anything about it.
I don't know about any of that, but I do know that if it bleeds, we can kill it.
Yes, that is true. If it bleeds, we can kill it.
Get to the chopper.
What's the last thing you saw Schwarzenegger in? Other than the news?
What's that?
What's the last thing you saw Arnold Schwarzenegger in, or you watched that he was in?
Wow.
Other than the news.
Oh my God, that's terrible. So honestly,
Kindergarten Cop.
The last thing that I can remember was one of his worst films, which was I actually saw it in the theater, Last Action Hero, and that's got to be what 20
Yeah,
years
that wasn't great. Yeah, that wasn't great. No. Yeah, I took a little trip with the Terminator the other day, so I'm good there.
I haven't seen any of the modern Terminator sequels. Haven't seen any of them.
I think this is pretty good. All right, so we'll get into the book now. So the Fermi Paradox. What is it? What's the Fermi Paradox?
The Fermi Paradox is the story goes that he was out to lunch with his buddies at Los Alamos one day, and a conversation popped up. Given the sheer numbers of stars, planets, galaxies in the known universe, the universe must be teeming with extraterrestrial life, and just sheer numbers alone would suggest that we should be visited now or have already been visited. And Fermi was famous for doing back of the envelope calculations and taking really complex problems and breaking them down and getting really good round approximations for estimates of things to try and answer hypothetical questions like this. And they did some numbers and calculations and figured, there should be thousands of civilizations that should be contacting us, but they're not here. Well, where are they then? That's the paradox. The numbers say they should be here. The paradox is they're not.
So I love how you said it was his buddies at lunch. These are like the guy who who's credited with inventing the hydrogen bomb, right? Teller was one of them, right?
Mm-hmm. Yep.
Leo Szilard, wasn't he here at that?
Yeah, so it was in the book, and I can't recall who the gentlemen were.
Well, the reason I say Szilard was there is because one of the things that Stephen Webb, and let's give Stephen Webb credit, this was really an amazing book. I thought anyway, I really enjoyed this book. And he's written several iterations. I read the one where there were only 50 solutions to the Fermi Paradox. You read the one where there were 75? Is that right?
Yeah, that's right. He felt that enough new research had happened since he originally wrote the book with respect to discovery of exoplanets, which we now have direct evidence for, and some other astrophysical breakthroughs that have occurred in the last 15 years or so. And
biological too. In fact, this book doesn't age well in certain parts, at least the version I read from 2002, especially exoplanets, because there has been boom, especially with Webb. Don't get that wrong. Stephen Webb is not the same Webb that the telescope is named after, but it's just a coincidence that it just happens to be spelled the same, but it's kind of an interesting coincidence. I love coincidences, but but yeah, I mean, they're finding planets like they're like, I don't know, almost daily, right? I think the last count that I saw confirmed there were over 5,000 confirmed in quotation marks, as well as we can confirm them. And then there are like almost 10,000 that are suspected or they're investigating. So that's a lot.
Yeah, it's a lot, and the science is getting more accuracy and specificity because the ability to actually investigate the chemical makeup of exoplanets that have
The
atmospheres
atmospheres.
is happening.
That's pretty wild because you get water, boom, it changes the whole equation, right?
Yeah, so that's a big part of the book is water is, we believe, key to life of whatever type it might be.
Well, at least the type that we know of, right?
Right. And that's one of the difficulties of exploring this topic is that uh, you have a natural bias towards what you know, and uh, all we know is life on this planet, and it's the only life that we know that exists. Period. We don't have any direct evidence of any other life anywhere.
That's
Yeah.
right. And it's one biogenesis. It's the only example. So when you proceed scientifically from one example in hypotheses, errors definitely ensue, right? So let's just state right now that like this is not all of these possible solutions to the paradox that we're going to talk about today are science fact. Some are along that road and others are sheer speculation. And so that's what I find is fascinating about this is that one need not be a scientist of a particular discipline in order to contribute to this to have an idea of a possible solution to this. In fact, one need not be a scientist at all. Writers have contributed to this. Obviously, many different disciplines of science. You could go astrophysics.
So
You could go. Go ahead.
yeah, there biologists have something to say.
Sure.
Physicists have something to say. Astrophysicists have something to say. Philosophers have something to say. Mathematicians have something to say.
That's a really big part of this.
Logicians have something to say because, as you pointed out, um, we don't have a lot of direct evidence, and many of these theories are based on extrapolations.
Yes, and that's the thing. It's not that's not science, right? So let's define science, right? So when we talk about science, when I talk about science, right, it's something that's verifiable,
It has to be testable.
testable, repeatedly. You can repeat the test, right?
Yes.
So that's a big deal here. So let's talk about the elephant in the room. Let's talk about the wow signal because that's one where like it seems to fit all of the testable parameters except it never was repeated.
Right. So this is a radio telescope observation that happened in I think around 1977 or so.
Ohio State.
There have been many attempts at looking for possible signatures of radio signals that would suggest an extraterrestrial or an intelligent origin. And one of the first saw a big spike in a particular frequency. Um, but when the equipment was pointing that direction on many subsequent opportunities, the signal was never received again. And a big section of the book is dedicated to the fact that, great, radio telescopes are probably going to be the one of the handiest tools in creating evidence for the existence of extraterrestrial civilizations, or what he calls ETCs. But there are many inherent problems in using that technology to locate that signature signal.
Because
Not
lots of
least,
things
not,
make radio noise in the universe.
there are many things that make signals which you might want to attribute to an intelligent source, but one of the key problems is the vastness of the sky and how little of an area you cover when you're pointing your various instruments. And you run up against this problem of, are you looking in the right place at the right time? What if the signal comes and it passes you by and you just don't happen to be looking at that patch of sky at that
Yeah.
moment? Your
Yeah.
chance of detection is it's gone, never to
It's
return.
Yeah, it's like the Hitchhiker's Guide to the Galaxy says space is big,
Really big.
really big. I mean, you might think it's a long walk down to the chemist, but that's peanuts compared to space. Like it is, I don't, and that's the thing. I don't even think I can grab. I know that there are and I go to like lectures at the observatory, and I like, I'm not like I'm a lay person in the fact that like I don't have the math to like understand like certain theories and things of that nature. But like I've delved into this for decades, and as a lay person who is not like in the academic discipline, I know a little bit about astronomy, and I still can't wrap my mind around the numbers. Like it's just
Nobody
vast.
can. It's these are imponderables. They're inconceivable. It's beyond. Well, you can't fathom those things which are outside of your experience.
Well, it's like
And
this. One I heard was like the number of stars in the galaxy is greater than the number of grains of sand on the beaches of the world. Is it something like that? Or is it the number of galaxies? But it's just like trying to compare something like that. It's just
yeah,
it
it
sort
almost
of
doesn't
tries to
even.
give you an appreciation of it, but I can't even get an appreciation of that.
No, and but it does get to the heart of the reason why people that can understand the concept of that kind of vastness are then convinced that, well, the numbers are so overwhelmingly huge that the chances of there not being life elsewhere
Yeah.
must be zero. I
All
mean,
right, let's get into that
yeah,
because I have a problem with that. It's like, when quantum theorists say, anything is possible, right? So because it's all percentages, right? It's probabilities,
probabilities.
probabilities, but there are infinitesimally small probabilities, right? There's a possibility that this computer mouse is going to turn into a loaf of bread, but it's a really, really, really tiny possibility. You know what I mean? Like and that's where I come from with trying to solve the Drake equation by just saying the universe is so big that the Drake equation equals one. Like that doesn't sit well with me, Like I don't buy it.
So you're saying that the vastness of the numbers don't convince you
Doesn't
that there is life elsewhere?
it doesn't prove that there's life elsewhere.
No, it doesn't prove anything.
No, it doesn't prove anything.
And I think and that's actually one of the arguments in the book is that there is no proof, and that while it is considered exceedingly likely, that's nothing more than a shot in the dark. It's improvable.
But to
Uh,
me, that's the paradox, right? So here's the thing with the book. So the book is divided into three sections, right? So basically, three types of arguments. One is they're here. Oh, they're here. Number two is they exist, but we can't detect them for whatever reason. And the other one is they're just not here. They don't exist at all. Like they're undetectable because they're not even out there. So when we talk about like,
there's a fourth one.
oh, go ahead.
The fourth one is that there is there's some physical limitation that makes distant travel through the universe impractical or essentially impossible.
Okay, so I lump that under the second category, which is they're out there, but we don't detect them. But you're right. There can be subsets of that. Absolutely. Does he redo that in the subsequent book? Is that
So
part of his
he
chapter?
breaks it down into this is actually one of the. I was glad you brought it up because that's exactly where I was going to start.
Okay.
That all explanations for the paradox fall into one of four categories.
Okay.
That space travel is really infeasible.
Yeah.
They could, but they have chosen not to visit us.
Very Nornus.
Third, that they have not had sufficient time to reach us because we might be one of the premier dawn civilizations in the universe.
Mm.
And then the last one, they've already been here, but we don't see them now. Ancient astronauts or whatever.
Well, that doesn't leave then there's a fifth category, which is that they don't exist. Right.
Yeah, right. So this is, and I think he chooses not to deal with that. Um, he admits that that's a possibility, or that there are some thinkers who have put that forth, or put another way, rather than just declaring there are no other extraterrestrial civilizations. One of the options is that we're the first one.
So that is one of them. That's funny though, because in my book, there's 20 solutions that fall under the category they do not exist. So it's neat that to see that he's revised that and revisited that. So that's really interesting. So we're gonna what's great is we've read two different versions. So you're gonna have a lot of examples that I don't. And so I'm really interested in that. But I'm also interested in, and I think maybe the audience would be too, because they've probably thought about this at least a little bit by now. Which one do you okay, so which one do you personally think is most likely, or which two or three? Let's put it that way. Like,
So I don't
what
think
do
I
you?
can.
If
Right.
somebody
Okay.
said you have to explain this, go for
I'll start with the first one that comes to my mind.
it. Okay.
One of the explanations that's been put forward is that the what he calls the ladder towards life,
Yeah.
the evolutionary development from
Prokaryote cells to eukaryote cells.
there's that the ladder from amino acids up to complex life forms, mammals and us and so forth, is actually very complex, and there are many opportunities for that ladder to be broken and for evolution to stop. So it's entirely possible that the universe is burgeoning with life forms, but not very few of them have become advanced. Maybe they stopped as cells and continue to flourish as simple cells living in a soup somewhere. Um, there's no reason to think that didn't happen. So this also gets into our feelings about what's likely and what's not likely
Mhm.
are all prejudiced based on what is known as the weak anthropic principle,
Yes. So
which
explain the weak anthropic principle, if you
it
can.
basically says that, um, of course, you're going to think those things are likely which you see around you. But to think about it another way, if a conscious life arose in only one location in the universe, let's say it's us, you would naturally think that the environment in which you arose must be common. But as you pointed out several minutes ago, there's no reason to believe that at all.
But well, so that is a supposition that comes from what they call the Copernican, like I can't remember what the noun is, but it comes from the idea that Copernicus had, saying that the Earth is not in a privileged part of the universe, or Copernicus was talking about the solar system. So like basically we're not that special. If it could happen here, it could happen anywhere or anything, anytime. So that is a predisposition that scientists use, and it works very well under most circumstances, right? So, but it is a supposition, right? It is not necessarily true, you know?
Right, right. So that we're just biased to think the types of things that we see around us are likely and common,
Yeah.
while not having any logical basis on which to believe that. It's prejudice based on
Yeah,
our own
it's a
experience.
bias. It's like it's a confirmation bias. It's like when my friend plays the daily number and he says, "I'm seeing the number, pick a number, 679 everywhere." It's like, yes, because there are license plates and house numbers and telephone numbers, and there are numbers everywhere. And now that you have one in your mind, you're going to see it everywhere. Those were always there, but now you're aware of it. So now you're seeing it. That's not proof that all of a sudden you're going to hit the lottery, right?
Exactly, exactly. So, and it's important when you're seriously tackling the question of, where are other civilizations if they exist, you have to be aware of that bias.
So what's
So
the strong? Do you know? See, the weak anthropic principle implies that there's a strong anthropic principle.
Yeah, and the strong anthropic principle, I just pulled it up.
Cool.
Part of the problem that I have with this book is that I don't think he's a very good writer.
I'm
um,
sorry, I have to agree.
he
I think
commits
he's
one.
a nice guy. I've heard him interviewed, and he seems like a super
Yeah,
nice guy.
but he commits one of the great writer's sins of putting in 5 words when one will do. So many of his explanations I found to be rambling, and I had to reread them multiple times, and they're not succinct. So, for instance, the strong anthropic principle, using his words, and I didn't
Okay.
look it up elsewhere. I could consult Wikipedia. Maybe they have a better explanation. It says that the strong anthropic principle is that the universe, and hence the fundamental parameters on which it depends, must be such as to admit the creation of observers within it at some stage.
Hmm.
So to me, I really had to, and I've already paraphrased it. I cut some words out of that to make it more direct
Thank you.
because it was more meandering the way he wrote it.
Mhm.
But to me, this gets back to the argument of sheer numbers again,
Mhm.
that the universe, that what we've seen so far, given the physical properties that we've observed and the vast numbers that we see, the likelihood that life would arise elsewhere must be huge.
So is this like the is it too far a linguistic leap to say that it means that the universe must make life?
So this is why I would like to get a better read a better definition of it, because that's one reading you could get out of it, but
Hmm.
that's a very philosophical
Hmm.
answer. It reminds me of a book that I read a few years ago that the basic title was "Why is there something rather than nothing?" And it's a similar question to what we're pondering here, except that it's not directly analyzable through science in most cases. It's completely the question of the mind, which is what I found so frustrating about it, because a lot of it seemed like linguistic games. So in that book, if you're out with your friends one night, you're camping and you're drunk, this is a great question to talk about. There's no reason that we know of for the universe to be filled with something. It seems it's equally probable that the universe could have been filled with nothing. There would be no planets, no stars. We never would have arisen, and consciousness anywhere would never have developed. That was just as likely an outcome. So the question is, why is there instead something?
I think if you're into the multi-universe theory, that all universes that are possible exist, I would have to say that the vast majority of them would be like that. Like at least would not be the type that would sustain our kind of life, especially when you start looking at different, like the different values of the different forces. Now this gets into the more of like the subatomic thing, but like, if the weak nuclear force is a little bit different, if the strong nuclear force, you know what I'm saying? And it
This
gets,
is this is about fine tuning. That there are
yeah.
about 5 or 7 constants in physics that, should they have been another decimal place off at the 12th number, um, forces would not exist that would hold the nucleus together. And there are a number of constants like that. That if they were tweaked just slightly in one
Just a
direction
little
or
bit.
another,
Yeah.
um, chemical reactions that life relies on would be impossible. Stable matter would be impossible, and on and on. So some people uh, take that fine tuning argument. They think that implies a creator. That clearly this demonstrates, because the tuning is so precise,
Somebody had to put all these
it
values in
can't
these
be
exact locations all at
it
the
can't
same
be
time.
random.
Right.
But to me, that's the same thing as the weak anthropic principle.
Right. Well,
That
I think it is the anthropic principle. I don't know if there is an adjective assigned to it, but the way I heard of it before reading this book was that the anthropic principle is the universe is such that we exist,
yeah,
basically.
and that of course, any beings that rose to consciousness in that universe would be inclined to think uh, there's something very suspicious about the precision of these numbers. Well, of course, those numbers had to be that way in order for life to arise and consciousness to develop. So, of
Sure,
course, you would think that.
sure. Yeah, it's tautological,
It's very
right?
circular. It's
Yeah, it's a
tautological.
tautology, I think. I think I don't think there's anything you can get out of that. I think it's an interesting kind of eddy in the thinking process, but again, but it's nothing that you can use scientifically to verify anything. It's
You
just
can't. And when I've seen it discussed elsewhere, it leads into discussions of uh, multiple universes, parallel universes,
yeah,
and
as it should.
it becomes incomprehensible almost immediately. It requires a thinking that uh, our brains simply aren't capable of, because and the only way that it can be explored is mathematically. And the mathematics that are necessary to really explore it are so complex. It's only accessible to a very few human beings.
So we got off.
It's not really science because it's not testable.
So we kind of got sidetracked though. So what is this is part of what you were explaining about what your favorite theory was. So keep going on that. So or you is it the multicellular life thing? Is it
So I don't know why I picked that one to start with. It's an explanation that appeals to me because when he walks you through what's necessary for cells to become more complex, to form higher organisms,
yeah,
uh, to eventually turn into a branch that's like us, there are so many places where it can go wrong
yeah,
that it again, if you fall back on the statistical perspective, it seems very much within the realm of reality, no matter how many planets that you're talking about that are potentially habitable, that that ladder could not be surmounted. And what if it's the case that we are unique in that we're one of the few planets that was habitable where we got lucky that life was able to surmount all those physical obstacles and the statistical improbabilities
right,
of all the things that had to happen.
right.
So it's one that I think that one's really worth considering. The other one that appeals to me as a solution to the paradox, well, there are multiples.
Well, but by the way, let me just add this footnote. I don't know if you watch or listen to the YouTube channel Event Horizon with the writer John Michael Gaudier. So he talks about different science papers and things like that. Really great. He's a sci-fi author, but he gets scientists, and Stephen Webb's been on his show many times. And that's John Michael Gaudier's favorite theory, is that the prokaryote eukaryote line is so difficult to cross that there's
Right.
probably
So
slime,
let's talk about that one in particular.
everywhere in the universe, but none of it can talk. So
Let's talk about that one in particular because I I read this book electronically, so I was able to cut out the parts that I thought were worth talking about.
yeah.
Um,
Oh
I,
yeah, good. Let's do that. That's
I didn't
perfect.
come up with that many of them, but
Well, that's better because then we won't be here all night.
that's true. Well, I think it's more interesting to focus on. There's enough meaty topics in this
Yeah.
that
Yeah, we can go away. We can do away with the ancient alien stuff. The discovery, I mean, the learning,
oh
or
no, that's not even in the book. We're not even
yeah,
talking.
they've beaten that horse to death. So if that's what you want,
That's
this
nonsense.
is not what we're talking about
Not
today.
for you.
Yeah,
So the cell
the
development.
Mayans did not invent television.
uh, Biology is not my strong suit.
I
I
don't
was
think it's Stephen Webb's either, to tell you the truth.
yeah, he's pretty honest about that. That
Yeah.
he doesn't claim to be an expert in all aspects of science, but
Yes.
this particular argument I found to be pretty convincing, and that is that there in the early stages of advanced life development, you have to make or at least life on Earth had to make a big jump from prokaryotic cells, which were tightly self-contained, to eukaryotic cells, which have weak containment, very flexible, and much more open to um, invaders getting inside. This is how it's believed that we wound up with the cell nucleus, which provides the power for all living cells.
Mitochondria.
The mitochondria, without which, cellular life as we know it would not function.
Nope.
So
Nope.
had life on this earth developed exclusively with prokaryotic cell life, it would essentially be a lot of these cells bumping up against each other, never transmitting mutations or combining forces, resulting in some kind of new biological mechanism. And biologists, evolutionary biologists, believe that transformation from prokaryotic cells to eukaryotic cells was critical in enabling evolution. So what if that transition from the first cell type to the second cell type is actually very tricky and statistically improbable? If that's the case, that maybe we're extraordinarily unique. Maybe there's only a handful of advanced
Instances when that
biological inhabited worlds, not even necessarily conscious, but advanced multicellular organisms. There might not be that many. We don't know. But that's another statistical argument.
So that's a filter, right? So what I get fascinated by is, see, my personal thing is, I love when when people talk about the great filter. They usually use it in the singular, but my personal theory is kind of a cheat because I think it's multiple filters, right? That may be difficult, right? It may also be difficult to find a location. The planets find locations where like they're not in bands of radiation, which make it inhospitable to cellular life. Gamma ray bursts are common.
You're going to be in the Goldilocks zone.
Yeah, astronomical events. Sure.
Your planet's too hot. Your planet's too cold.
But to stick with the biology thing for a second, one that came to me last year, I read about this, and I had not really ever heard of it before, is the phosphorus problem, right?
Say that again?
The phosphorus problem.
Oh, phosphorus. Yeah, go ahead.
So apparently phosphorus is hard to make, like in stars. So, and it's hard to make in enough density to be useful to life as an energy source. So like, again, with the biology thing, which again is not one of my strongest sciences. I'm not a big life science guy. I don't know that much about it, but I know enough to know that the ATP, ADP cycle, the P stands for phosphorus. And so it's necessary for everything. Everything that lives on Earth uses this cycle, right? As far as I know, definitely multicellular life. So it's, but apparently phosphorus is not very common in the universe.
So this kind of gets at the heart of this is a chemical cycle that is critical for the type of life that we know of on this planet.
Right.
Which then brings up the topic of what other kind of life forms could there be?
Right.
Everything we know is carbon based. I think that most people who speculate about these things would expect most life elsewhere to also be carbon based, but there's also the possibility of being silicon based. That's another material that's been hypothesized, but we've never seen such a thing.
It's been hypothesized, but it's also been I've read where certain scientists have tried to take that theory further and tried to figure out solvents and chemical properties that would enable silicon, and they found that it would be really difficult for a silicon-based life form to even exist. So it's neat in the terms of science fiction, but in as much as we know about chemical bonds and like what actually happens, it seems very difficult, like so much more difficult than carbon. So but the thing, so yeah, I mean, if you want to be like if you're a sci-fi author and you're writing about helium and hydrogen based life forms, yeah, then they can exist pretty much as soon as the stars do, right? But for us, we need several generations of stars, right, to explode before we can get. So the universe is, as far as we know it, 13.8, a little less billion years old. But like our kind of life, there's not enough complex metals, they call them in astronomy. Anything that's not hydrogen and helium is called a metal. But basically, anything more complex than that, it doesn't happen in enough abundance to even form like terrestrial planets. Until what?
You
The
have to
third
wait for
generation?
stars.
I think it's third generation stars. I have
You
to
have to
look
wait for
that up
stars
again.
to go through
But let's
their
say I think it's like 6 billion years or something like that. It's not half the age of the universe, but it's a significant portion of the first half of the universe, right? So
right. You
so
got
that
to
cuts
wait for
down
those
the
stars to
window
go
of
through their
time that
cycle.
civilizations can exist,
Right.
right?
Yeah. So you have to wait for there's a good length of time that you have to wait in order for those elements to be produced by stars that have gone through their complete life cycle to explode, push the products of fusion and fission out to even be available to form planets, and then for those elements to be somehow incorporated into.
See, I'm so glad I'm talking to you about this because you have an understanding of physics, so you can verbalize these things in a way that is intelligent, but other people can understand. So when you said fusion and fission, and that's wonderful because I don't know that I would have said that. But the counter argument to the argument that, oh, well, there's only been a short amount of time for life to exist is that since we exist, it can happen, and the amount of time it would take to populate a galaxy like our galaxy, even with chemical rockets at the level of technology we are at now, is in like the 10 million year range, or maybe even if you go another factor up, 100 million year range, which is a really infinitesimally small fraction of the remaining, we'll call it, I don't know, billions of years, So why aren't they out there? Why don't we detect radio signals? Why don't we see superstructures around stars? Why don't we see Dyson swarms and spheres? Like what's going on here?
So the Dyson sphere thing, I've never understood it because So he talks about he breaks theoretical extraterrestrial civilizations into three types: K1, K2, and K3.
Kardashev scale.
Okay, you remembered that, and I didn't.
Yeah.
And it's the relative power or mastery that a civilization has over its environment. And I forget what the various scales are, but 3 is when you're essentially godlike. And the raw materials of the universe are available for you to be harvested and used at enormous mind-numbing scales.
Yeah, like we can't even conceive of it.
Yeah, I believe it's a K3 civilization that would be capable of building a Dyson sphere, which is
no.
Is it 2? Is it K2 or K3?
I thought it was this way. I thought it was K1 is a planet. You can, and then K2 was a star, right? So K2 is the Dyson sphere, I think.
Okay. You might be completely right.
I think.
I couldn't remember.
I might be wrong about that, but I think that's what it is.
So
K3, man, Dyson spheres are like child's play. They're like Tinker toys, at K3.
Right. And see, this is kind of hard for me to imagine. Maybe it's a failure of my imagination, but a Dyson sphere posits a civilization that could build a structure that would completely encase its sun,
right?
Thereby harnessing 100% of the energy output of that star.
Right.
And this is probably a step on the way to being a K3 civilization, where you have unlimited power and energy at your command because you're just directly harvesting from stars.
Oh, who doesn't want unlimited power?
Well, it's inconceivable to me the amount of mass that would be required to build.
Yeah, there isn't enough mass in the solar system to build one of these things, right?
Yeah, right. I mean, if you disassembled every planet in this solar system,
right, you don't have
enough matter to build a shell around the sun.
So now they've modified the theory to call it swarms, and then they even have the ring world theory, where you just So, but those kinds of superstructures should obscure enough light from certain stars that we should be able to detect that. And that's the argument. So Tabby star, or like this other one that came up just a few years ago, and they were trying to figure out why the star's light was occulted at certain times, and they were trying to figure it out. They couldn't figure it out. To me, it's like, well, it's probably just an abnormal, Oort cloud or something. It's
I think it's
dense here and it's not dense here. But but that's me because I'm a logical. But I'm sure
I think most serious scientists would would go for, Occam's razor, right? You go for the
Right.
obvious explanation.
Yeah.
Not that it's evidence for a Dyson sphere,
Yeah.
which
Don't jump to
Dyson
conclusions.
sphere is is a really fun intellectual idea.
Yeah.
In real life, I just can't.
It just can't be done,
It seems
right?
preposterous to me.
Well, it would take forever. And think about the labor power. You know what I mean? I mean, even if you have automated machines, it would just take forever.
Pat,
Although,
can we pause for just a moment?
yeah, I agree. I need to take a pause as well.
Just a second.
All right, we're back. Aaron Blanson and Pittsburgh Pat talking about the Fermi paradox. And we were talking about machines. Let me go and jump ahead. One of my favorite theories is the gray goo theory. I love the gray goo theory because to me, this seems plausible. So Wesley Crusher invents nanites and he like lets them out on the ship of the Enterprise, right? And Guinan, you remember this episode? It was called Evolution. And Guinan like is like, oh, well, Dr. Frankenstein, let the monster out. And so now he has to go find these nanites before they like start consuming things, presumably like organic matter and turning it into some kind of energy and then waste product, which is this gray goo. So the idea is this is like some kind of like apocalyptic scenario where civilizations become advanced enough that they invent these tiny robots that are automated and somewhat intelligent, so that intelligent enough they're autonomous and they can do things, but they get confused. Programmer gets confused, they get haywire, and they replicate and they just consume all the consumables on a planet. And so you find a planet that's basically like, well, there was organic life here, but now there's all this waste material because these, automated robots destroyed it. And I just find that kind of is I don't know, it's kind of fascinating because it's typical of the kind of self-destructive theories that are in here, right?
So this leads me to the Drake equation,
Yes.
in which uh, uh, Francis Drake, was that his name? I can't remember. Am I confusing it with the Explorer?
Yeah, the Explorer. I forget what his first name
I don't remember
was.
his name, but anyway,
Yeah.
Frank Drake, not
Oh,
Francis.
you're right. Yeah. Well, maybe his
Um,
mom called him Francis.
so I think it was probably another casual conversation topic amongst educated scientific types, and he decided to tackle it and get some round, figure out a way to estimate. What's the likelihood of civilization successfully navigating these filters, as you call them.
Yeah.
There's the biological filter, but one of the most important filters in that equation is the likelihood of self-destruction. And the gray goo is just, or nanotechnology run amok, is just one of several prominent technological doomsdays that we can imagine.
These are the fun ones to me. These are the ones that like, I don't know, maybe I'm a masochist, but I just love I love sci-fi stories that are, well, sci-fi is always, I don't know. I don't want to make blanket statements. A lot of the sci-fi that I like is cautionary, right? So
Most science fiction stories are cautionary. That's kind of its bread and butter.
right. So like the Terminator, don't build Skynet, don't do it. And yet we're doing it.
Well,
right.
so the interesting thing, and he doesn't pay a lot of attention to this in the book, and I think it's because it basically ends discussion. Because what else is to say after that? If you think it's very highly probable that an advanced civilization, as soon as it develops advanced technology, is a very short jump from the discovery of that science and technology to annihilation. On the cosmic scale, it's
Yeah.
a nanosecond.
2 seconds to midnight, right? Or 2 minutes to midnight, whatever the atomic clock.
And that's basically where humanity is. That we went from steam power to increasingly sophisticated artificial intelligence, nuclear weaponry, ecological disaster.
100 years?
In 100 years, right?
Yeah, railroads to like the moon in 100 years, right?
Right. And the interesting thing to me about that is that when I first became aware of the Drake equation in the early 1980s because of a certain show, the concern then was overwhelmingly, it was Cold War concerns, nuclear annihilation. It seemed highly likely that an accidental conflict would occur between the two great powers. But now, in just another scant 30 or 40 years, we've added many additional, also very plausible doomsday scenarios for our civilization. So that, including climate change, um, artificial intelligence is now a very concerning one, although
Yeah, every day of the week you hear about
people
it.
may quibble with me about that, but I'm concerned about it.
No, I'm on your side, brother.
Uh, biological warfare.
I've even started to be, on my wife's advice, I've even started to be nice to Alexa. She's like, be nice to Alexa. I said, no, you may be right. When the AI overlords come, they may because they'll have a record of every interaction that you had with Alexa. And if you didn't treat her nice, it'll be the Santa's naughty or nice list, maybe,
I take constellation safety in numbers. There are so many other people to worry about. They won't have time to get down to my level.
Security through obscurity.
It seems to me that the a consciously aware, sophisticated tool-making species, uh, the harnessing of technology and science outpaces and outstrips their ability to control it.
Yeah.
We certainly don't have the ability to control
No.
the things that we've harnessed and discovered. I have to imagine that this is one big leading contender for why we have not encountered other civilizations, remotely through radio beacons or whatever it might be. That the likelihood that a civilization discovers advanced technology and then virtually overnight snuffs itself out.
I agree, and it's because I was having a debate in a parking lot last night about this. Where all great debates happen. You get kicked out of the place where you are, and you still want to have a conversation, so you're out in the parking lot talking about.
I'm not telling you can't talk about extraterrestrials anymore, but you can't.
But you gotta do it somewhere else. That's right. You can't do it here. So that's what we were doing in the parking lot, and we were talking about. I was talking about. I probably shouldn't. I won't get into details, but it's a possible solution to global warming that would have catastrophic effects for certain people who have breathing problems. And that's all I'm going to say. But here's the thing. Nobody's really regulating this. Not too many people even know about it. And yet there are people that are experimenting with this, and they're not doing it in the United States, and they're not doing it in Europe. They're doing it in places that don't have very strict regulations on what you do, and welcome billionaires who want to spend any amount of money under their jurisdiction. And so all it takes, the point is, all it takes is one, maybe a dozen, or a couple hundred, or maybe even 1,000 individuals to disagree with whatever the standard is. So even if you could get people to say, okay, no gene splicing. No, we're not going to, it's terrible. It's going to be dangerous. Don't do it. Don't alter the genome. Somebody's going to do it. Don't make nanobots. No, man, you let those things out, they're going to eat everything. It's going to, somebody's going to do it,
Well,
nuclear weapons.
The whole idea of that
somebody's going to do it, right? The whole argument with why we should make nuclear weapons, the whole argument with that Albert Einstein wrote a letter to FDR, right? Why should we develop nuclear weapons? Because somebody else is going to do it, right? So that impetus is there, and I know maybe that's my human centric. Maybe there are hive minds out there like the Borg or some insectoid species that thinks alike. All the beings are all on the same page all the time. But I don't think so. I think intelligence is going to be independent, and it's going to be innovative, and it's going to be self-destructive, whether or not it wants to be.
I listened to, there's so much stuff online. The world's knowledge is out there. And I stumbled across this archive of everybody who was associated with the Atom Bomb Project, and they interviewed them, and they were from all different decades. And this was an interview with Oppenheimer towards the end of his life. And the interviewer basically said, the atom bomb, which you've come to really be against, why did you and all the other top scientists work on this horrible thing? He said, well, when you have the best minds in the world at the time, and this is a paraphrase, it was the coolest problem around to be working.
Wow. Wow. That's wow. Oh my.
Now he didn't say cool, but paraphrasing, that's basically what he said. It was the coolest
Okay,
problem to solve.
that's not where I thought you were going with that, because I heard Philip Morrison interviewed, and I don't know. He's in my pantheon.
Oh yeah, yeah, he's very interesting.
Oh, dude, it's, I mean, he was a regular contributor to Scientific American. He had a column I would read religiously when I subscribed. And like, he was really young though, okay, during the Manhattan Project.
They
He was
all were.
like a graduate student or something.
They all were. Most of them.
But he said like, presumably, remember that documentary War and Peace in the Nuclear Age? Oh my God.
Forget it.
Learned so much from that. The first episode, they talked, all these scientists are still alive. And Philip Morrison said, here we were, very comfortable, relatively to everyone else during World War II in our country, very comfortable conditions, and we were reading and we were getting news reports over the radio of our friends in these distant locations fighting and dying. And we were given this project to do that could presumably save some of their lives. And we felt remiss if we didn't do our darndest to make this happen. So like, that's not, Oppenheimer was like, this is cool, but like Morrison's like, this was not only my patriotic duty, but it was my duty to my fellow human beings to like help stop this war, and
Yeah.
and so like, I mean, that is a logical argument to me, and I mean, now I don't pretend to understand what alien politics would be like. Would nation states exist on other planets?
We don't know if they would have a culture per se. And this is actually one of the problems that I have with the book.
Right.
Is that he spends a lot of time just assuming without any justification for which is odd, because he really analyzes the presumptions of almost every other argument. But one of the things that he constantly goes back to is advanced civilizations, they're just going to spread out across the galaxy. That it's just going to happen. And it's never questioned that they wouldn't do this. And not only they're going to inhabit their own solar system, but they're going to journey to distant solar systems, and they'll try to go to other galaxies. That's a weird supposition to me to make. I don't think that's logical at all. I mean, it could certainly happen. It's statistically possible, like any other possibility. But I don't know why so much of the book is based on assuming that a spacefaring species inevitably is going to go on a colonization campaign far afield.
Yeah, when my friends, and I have many of them who are really big about Mars, right? They're really big about it. They think that it's doable in like our generation or the next generation.
Fine, you go.
Space is trying to kill you.
Always.
Right? There is nothing, we talked about this when we did 2001. Actually, you talked about it. And I've thought about this many times since, is how Kubrick portrayed space as being cold and impartial, does not care if little squishy, warm-blooded human beings are there or not. It does not know or care.
So let me go on a small tangent. I mean, these conversations are always about tangents, but you say one thing and it makes me immediately think of another. And I don't know if we talked about this before or not, but was it last year, 2 years ago, Shatner went up on that publicized Bezos trip.
Yeah.
And his immediate reaction when he came back, he said it was intense sadness, because he felt this malevolence beyond the Earth's atmosphere, that it was an uncaring void that had no pity for life. And then I heard him later when this is months later, he had a chance to do an extended interview, and he said that feeling had not died down in him one bit. It hadn't eroded in the slightest bit. He felt that more strongly than ever, that this ball right here, this is it. This is the heart of life, nurturing and all the rest of it. Out there is death, essentially.
Yeah. I mean, we're fools. I mean, you can look at it one way. We're fools to be hurling our bodies. I can't remember what sci-fi movie or what that was from. It's like, you humans hurling your bodies into space. You have no idea what you are doing. Something like that. Some big bug-eyed alien saying that. But for me, the only realistic way that we become a spacefaring species is if we alter our species, right? So I mean, if you really want to get to Mars, I say genetic engineering first, right? So you have to figure out a way to make sure that we're heavily shielded, from all the radiation that's out
the
there.
primary problem.
I mean, it's just too big.
The main problem is radiation.
Of course,
it's
everywhere.
the killer problem.
Yeah. So this brings me back to the book. How many planets are out there? Great, they have water. Do they have an ozone layer? I mean, like, without the ozone layer, we're toast, right? I mean, there's no question.
This is again back to the argument about the ladder.
Yeah.
Of things that have to be what's the word I'm looking for? Not superseded. When you get over something, you get over an obstacle. You
surpassed.
What?
Surpassed?
No.
That's too simple.
I can't think of the word. Anyway, you know what I mean. So yeah, right in there with the Goldilocks problem of being the exact right distance from the sun.
Right.
The development of an atmosphere that shields the surface dwellers or whatever life might arise from radiation that would be lethal to it.
A magnetic field
barrier has to be surmounted.
Surmounted.
Yes. So
surmounted.
We take it for granted that a rocky metallic planet like the Earth will develop an atmosphere.
Right.
Maybe not. Can life develop without an atmosphere? Not life as we know it.
Or will it have a core and it was surrounded by a molten core that will spin at such a rate that it generates a magnetic field that will shield it from its sun's all the stuff that it like throws off all the particles and everything else.
He talks about, so if you get into all the filters for putting the biology aside for a moment.
Right, just do the space stuff
the
and all the
planetary mechanics. The planetary mechanics are a big deal because
plate tectonics.
Plate tectonics, the tilt of the axis.
Yes.
How many degrees it is? If it's flat on at 90 degrees, the likelihood you're going to get life arising is very close to zero. Or if it's tidally locked, the way the moon is tidally locked with the Earth, so that we see the same side. If that would happen, you had a planet that only the one side faced the sun, its star, constantly. Likelihood of life arising.
Is Mercury tidally locked? I mean, Mercury's too close anyway, but still, I think it is.
What?
Isn't Mercury tidally locked, or am I wrong about that?
I seem to recall that it's really close.
Okay.
But I don't know the answer. I think it's
not 100%, but it's still too close anyway. But the thing is, like, okay, and then we've already talked about this on a couple different occasions. I forget why, but we talked about the moon and like the fact that the moon, in comparison to the Earth, it's really the Earth-Moon system, right?
Yeah, it's considered
a double planet almost, because the stabilizing effect of the moon on the Earth's axis, axial tilt, and the fact that the moon causes tides. There's another one where the astronomical, I'm sorry, that was terrible. I gotta edit that out. Astronomical effect. And I have to tell you the story. Okay, so one time I'm going to go to the observatory and listen to an astronomy lecture, and I told somebody at the place where I was working, and she said, "Oh, I'm a Cancer," and I was like, "Okay, you know what? We're done. We can't even talk." So I'm sorry I made that mistake.
We can't talk.
Yeah, that was a slip. That was a slip. But the astronomical and the biological being linked, tidal pools. There are a lot of people that think that tidal pools are necessary to for amino acids to like mix, and the whole. I don't know enough about it to be able to talk about it authoritatively, but it's definitely part of the idea that just that is like a filter. So, not to mention worlds that are entirely water. Like dolphins could be super smart, but they're never going to make fire because they don't have any opportunity to make fire. So they're never going to make rockets. So they're never going to go to space. So how many plants out there could have intelligent aquatic life? They have squids and never be spacefaring.
That's kind of a laugh line, but at the same time, absolutely true.
Possible.
So this gets to another point, which is that you could have worlds that are in the Goldilocks zone. Everything's right, liquid water, an atmosphere shielded from radiation, all the right chemicals, complex life forms. But yeah, what if it's completely aquatic, or what if it's completely gaseous? So that that tool making becomes improbable or impossible.
Well, that's another thing. Okay,
the chain stops right there.
What if it's paradise? Okay. What if it's a super Earth? It's awesome. It's abundant. It's got all the things you could ever want. Why would you leave?
So again, this gets back to one of my big problems with his supposition that any advanced civilization will just naturally colonize and expand ever outward. That's why. I don't know. I don't know why he supposes that. I'm more in. So let me back up a stage.
Yeah, good.
There's one topic leads to another. One of the other things that he talks about is that he doesn't really pay it much attention. And this is sort of related to the Drake equation also, that if intelligent civilizations, self-aware civilizations, tool-making, technologically advanced civilizations develop, what's the likelihood they'll just be engaged in perpetual conflict, much as we are? Now, there's no reason for another civilization to be like us. We know that we're much like our ape cousins who are on a different branch of the evolutionary tree, but they have the same kind of militaristic behavior. And so it's not necessarily a given that an advanced civilization would be in contention with or would have various factions. But, and this might be the anthropic principle, it seems highly likely to me that it's not going to be paradisical, and they're not simply going to be beings of completely higher ethical realms, and that there will be conflict. So any planetary group of beings will have conflict that will naturally tend to prevent any kind of outward expansion.
Well, let's talk about that. Okay.
So, for instance, how did the Klingons ever develop faster than light travel? There's no way that would happen. Never.
There's no honor in research.
This is my problem with the Klingons. They never would have developed any kind of sophisticated science because they couldn't even share a meal without killing each other.
Oh my God. So, and then there's the one where Crusher, Dr. Crusher invites a bunch of scientists on board, and there's a murder mystery, right? And one of them is a Klingon engineer, almost a contradiction in terms, she says. What? They got complex machines.
They have faster than light ships.
They have no engineers. What, they all pack leads back there, like doing their repairs? Give me a break. Oh, terrible.
So I think this is another huge reason, another big filter in the Drake equation, that any intelligent civilization would have to overcome their own internal conflicts. And that again, I'm biased because I only know what we see around us, but that seems like a really big factor.
That's a big factor. And okay, so let's I want to hit 2 points. So some of these are a little bit off. So the one I'm going to go to, which is, okay, aliens exist and they're here, right? So if that's true, right? So I have to just say, here's what we would do. Okay. If we went to Europa, let's say, and we go through the ice shell.
Attempt no landings there.
Yeah. Now, all these worlds are yours except Europa.
Don't go.
If we went, even after getting that message from the monolith, we'd go. And you know what we would do if we found life there? We would go and grab it and put it in a jar, and we would dissect it, and we would throw acid on it, and we would make, and we would do test after test, and we would not tuck it back in. And we would not tuck it back into its beds, and we would not let it live the rest of its life. No, We
No,
would,
but you know that the aliens who created the monolith would have created some kind of shielding system that would be impenetrable.
oh, I think they deal with that in
They tell you not.
2061
They
or
tell
something
you
like
not to
that. I
go there,
read
but
the book,
that's
but it was so long ago.
when they tell you not to go there. That's just a courtesy. You're not going
Yeah.
to be able to go there.
Yeah, you're not going, but we're just going to tell you. Yeah. Mhm.
Like so that way you can say, "We warned you."
Yeah. I think that happens. I think what happens in 2061 is they crash land, somebody crash lands. But so they don't voluntarily abrogate the embargo. It was an emergency. But I forget. I read that a long time ago. The yeah, so like what I'm saying though is like, you know, that's one thing. You know, we're violent. We would do that in the name of scientific research. We would take an organism and just tear it apart, you know, not knowing whether it was like intelligent or not. We would just like, we would do it because we want to find out more about it. That's what we do. The other
So
thing,
there's a curiosity aspect to, again, this is our bias because we think
we think
that,
all intelligent life would be curious.
right, and this is actually well, that's a slightly different discussion, but yeah, that's another assumption on our part that is not necessarily true. You could have advanced life forms that simply aren't curious.
Well, maybe they stay home. So like maybe they are so maybe what happens is their level of technology becomes such that they can create the matrix. They can make whatever internal reality they want. So they don't have to leave and go to the dangers of space. They can just stay home
So
with their
this seems
planetary shield and like any incoming, you know, it's strong
this
enough to
seems much more
deflect any
likely.
bombardment. And they can just, you get that line, right? And they can just, you know, they put up their shield and they can go put their virtual reality helmets on and they can do whatever they want. They can go skydiving, they go explore the universe, they can do whatever they want, but it's in a computer matrix. Right?
So that gets to something that does make sense in his theories. If we set the colonization idea aside,
Yeah.
Other civilizations might decide to explore with probes only.
Yes, I love this idea.
We're not going to fly through the galaxy
No.
putting bodies into ships because that seems
No.
silly.
Well, it's expensive.
We can send remote probes,
Yeah.
and we don't have to jeopardize our lives or have multi-generational spaceships and all the rest of it.
Well, this was an argument against the manned space program, you know, for ages, and still is that the amount of money it would take to like do a manned space program, you could take unmanned probes and just like litter the solar system with them.
Well, and
that's
what we've done. That's
yes,
what we've done.
We've done that.
And with Mars, this is my argument against manned missions to Mars. And I have this discussion with a mutual friend of ours, and we're on a kind of opposite scales on this. That the technology for remote exploration now is so exquisitely advanced and just gets better all the time.
Yeah.
We're going to be sending submersibles to Europa within our lifetime. No question about it. We're going to be sending flyers to Jovian moons to fly through the atmosphere. There's no reason to go there in person. There's none. You know, remembering that discussion about how space basically wants to kill you.
Yeah.
But you want to know what's out there. You can have the best of both worlds.
Yep.
Your high technology will allow you to explore it from the comfort of your own home.
Well, this is why I don't go to football games.
What's that? Yeah, exactly.
Why don't go to football games? Why would I go and freeze my butt off with a bunch of drunk, you know, people when I could sit in the comfort of my living room and see it better, right?
Yeah.
Instead of being that far away from the field, and I had to look up the jumbotron, which I can't see as well as I can see my own TV set.
It's the same concept to go to Mars. Yeah,
pretty much.
Yeah. So he does talk. He does talk a lot about probes and why haven't we seen probes yet?
We have, right? So Anu Maga, I can't pronounce her name. The Anu Maga.
Oh, that thing that came through the solar system.
Yeah, we think it's interstellar, right? We think it's from outside our solar system. Yeah. I don't know how. I wish somebody could explain that to me. But we believe it's an extrasolar object, right?
Yeah, I don't know why either. Maybe it has something to do with its trajectory. That
it does.
It has such a course that can't be explainable as an orbital type of thing, even with a massive period around the sun. I don't know.
It's something like that. but I don't understand it. So yeah, so they have these probes, and they call them von Neumann probes or von Neumann probes. I can't remember. I don't know which is the correct pronunciation.
I'm not sure.
I kind of like Newman because it's like Newman, but
I think it is
you
Neumann.
know, they, but like, you know, they're annoying and they're there and they're ready. And the theories, there's a couple theories behind them. One is they're watchers, you know. The one that I particularly like is that they're gardeners, right? So like they're waiting for us to go to Mars. As soon as we prove that we're capable of doing that, they wipe us out.
So this brings me to another thread that I have on my list here. If I can just find it again. Oh yeah, here it is. I'm gonna hold this one up.
No desire to connect. If the galaxy is home to 1 million civilizations, as optimists suggest, then perhaps some of them have no desire to communicate with others. But to explain the paradox requires all civilizations. Exactly. It's the same with the nanotech. Somebody's going to break the treaty, right?
Right. But this would also, maybe there's one or two that break the treaty, but what if the preponderance of civilizations out there just are not interested? So it seems unlikely, again, only because of our bias, because we're a naturally curious species. Perhaps not every species is. And we're desperate to know, like, is there any other intelligent life out? Is there any life period out there?
Mm-hmm.
Maybe there are other civilizations who are like, who cares?
Well, or they've searched for 10,000 years and they're like, we're wasting our resources. Let's do something else, because the chances of us coexisting at the same time with enough close enough to each other to be able to confirmably detect. And then what is the benefit of contact anyway?
Right. And he raises
what are we going to communicate? How are we going to communicate? And even if we could, what are we going to communicate?
I think that's a great argument, that if you were a super sophisticated K2 species that is fully capable of interstellar travel or intergalactic travel or however you're getting around,
right,
what interest would you have in making your presence known to a species that to you would be like amoeba? There'd be no benefit. There would be no advantage. You'd be happy to observe them from a distance and just confirm, oh, look at that. There is other life in the universe.
How interesting.
How interesting. Yeah.
Yes.
And I could publish an article on that. I'm done. But,
yeah.
but I don't want to try to talk to them.
Well, that's okay. So this is a great one that some people have come up with, and is fascinating, and it's been used in sci-fi as a trope. Is the human zoo, right? So there are civilizations out there, but they have shielded themselves from being detected by us, but they let us live for whatever alien motivation they have. One, which is interesting, is that, well, maybe we'll come up with something interesting that they haven't. So they'll keep us alive, contained, and then they'll check in periodically and go like, oh, well, that's an interesting theory of physics. We never thought of that. Maybe we can take a little kernel of that and we can use that over here, or something like that, you know? So ultimately, we could be, you know, there's the computer simulation theory, but this would be more like we're a laboratory experiment. We're like we're on Agar, and we're I wonder how fast this will populate, and if anything interesting will result from it. So we're like that kind of
So that's a fun sci-fi idea, but I don't find that one to be
seems very impractical.
I don't find that to be a persuasive argument for why we
I agree.
An alien species.
Here's one that I like, which could be a great sci-fi. I don't know anybody's written about this. There probably have been. I'm not as aware of sci-fi as I was when I was younger, but all the writing, I mean. And this one is, eventually biological life evolves into machine life somehow. We're able to either transport our consciousness into some kind of
transhumanism.
Yes, we're either able to leave our biological shells, which are squishy and only have a few hit points, and we can put ourselves into machines, right, and replicate them. And so we keep our ideas and consciousness alive in some form, and then those machines can go off. and it's easier for machines to travel in space. In fact, there's an advantage to machine civilizations going to the furthest edges of space where it's really, really cold, and so that they can perform as many teraflops as they want and dissipate their heat faster so that they can do whatever it is that
Yeah.
those machines want to do.
So this was I read that. I remember reading that argument, and that was one of the weirdest arguments.
Yeah, isn't it weird? That's why I'm fascinated with it.
Uh,
Because isn't space cold enough? I mean, how much colder does it get at the edges of space, right?
I know, and that's why I just could not understand the basis
Yeah.
of the argument at
Yeah.
all. It seemed
It seems
perfectly
implausible, but it seems like a great sci-fi story plot.
sure. Like I got to travel to another galaxy because I just have more heat output than this locality can possibly sustain.
It's just this is just way too warm up here, guys.
I need intergalactic space to radiate my heat. Yeah, that was a super weird one. This is again part of my problem with the book. There were a number of things like this that were just like they were so out there. I'm like,
They're reaching.
why did you even put this in the book?
They're reaching. I don't know.
Here's one I've got, and it's another filter
I love filters.
that resonates with me because it's something that I think about by nature of the job that I have. I work at a place where people research these kinds of things. That we might be like the physicists of the turn of the century from 19th to 20th, where they declared confidently, physics is solved.
Over.
We now know how everything works. There are only a couple pesky questions left, like black body radiation, but we'll solve that one. And of course, that's the problem that instigated quantum mechanics and upended Newtonian mechanics and created a whole new vast realm of physics to be explored, which only took about another 100 years to fully explore. So now what I'm getting to is that modern physics has reached this point where the questions that remain to be answered, things like where does the proton get its spin? What accounts for the proton's mass? To physicists, these are interesting questions, but they are of no obvious practical value, and that probably sounds that might sound elitist because somebody else might say, well, if we knew where the spin of the proton originated from, that would give us the clue to how to build the transporter, or some other miracle technology. Okay, that's possible, but it's more likely that these are just interesting academic questions that have no inherent application for anything anywhere. So what he writes about in the book is that we can now pose questions that are interesting, but are unanswerable. Because, for instance, there are certain physics questions where the machine that you would have to build to investigate it would be, a planetary diameter. It's impossible. You can't build such a machine. The technology doesn't exist. So these questions.
We're going back to Douglas Adams again. Like, is this you build the machine that will answer the question to life, the universe, and everything? It's the
that was more of a philosopher's ultimate doomsday machine. But his premise in this particular point in the book is that a species can be aware that there are intriguing questions about science and physics and chemistry, but also at the same time know that they are powerless to answer them, and they've reached a dead end.
Yeah.
What if this is the fate of all advanced civilizations, that
science has an end?
That science has a practical end, that those questions are still there, but you no longer have an ability to investigate them. So for another example would be that a lot of modern physics relies on mathematics that are theoretical only and that are not testable. Right. And many people argue that this is no longer science because testability is a requirement of science. However, the quantum phenomenon that we see, the only explanation that we can offer is a mathematical one that can't be tested. So where does that leave us? So the basic point is that it may be one of the answers to the Drake equation. or to the Fermi paradox,
Mhm.
is that every advanced species gets to this point and just hits a wall. You know, like we can't go any further. We're never gonna. We can't achieve close to light travel. We can't create space beacons. We can't create Dyson spheres. We can't do any of these things because it
Can't
requires
slingshot around pulsars and
it requires a technological leap that we just can't make. There's a barrier for us.
or practically can't make. Like we were talking about Dyson spheres. You just don't, yeah, we can conceptualize them, we can draw plans for them. We don't have enough materials,
Right.
you know.
Right. So I kind of I like that idea because and maybe it's my makeup. I'm more practical. I'm not as much of a dreamer, which is it's a good thing I'm not a scientist because scientists are propelled
Oh,
by that sort of feeling. But in this book, he doesn't deal a lot with things that I find very credible, things that are kind of like boring explanations.
I like the boring explanations. I think they're more interesting because they could be true. I don't get me wrong, I like the fantastical ones because they're good plots for stories. I
They're
like
fun to
telling
think about.
stories. I like listening to stories. So like it fires my imagination, but I can look at them and say very unrealistic. In fact, I've been doing a part by part series on my channel, but and I started a new channel just about this, and it's just, you know, where do you think? So I give it like a rating. I'm like, well, this is probably a 3 out of 10. This is probably a 1 out of 10, you know? And what do you think? You know, so people can chime in. But, you know, I think there was something that you said that I wanted to comment on. And now I'm having a moment that I can't
We're
quite.
throwing out a lot of ideas. It's hard for both of us to keep up.
Yeah. Well, no, I mean, there's so many. But I know what I wanted to talk about. So I go to this astronomy lecture once a month, going what's today? Wednesday, Friday. And at one of them a few years back, and I used to do this with this one cosmologist, and I got to know him afterwards, and we talk. And he had enough of a sense of humor about himself that he was able to take my joke. And I went up to him after the lecture, and he was talking about really grandiose ideas about cosmology, the origin of the universe, and why the Big Bang Theory has holes in it, and why inflation is kind of like, and like, so we were talking about it afterwards, and I said, all of this is really interesting, but it doesn't matter, does it? It ultimately just doesn't matter. Like, how does it affect anybody's life? And there's really no like practical science that comes out of it. And he just kind of like smiled and he went, "You're right. But do me a favor and don't tell a whole lot of people that."
So that's a really okay. I'm gonna. You can cut this part out. I'm gonna go deep.
We can pause. Let's pause.
I'm gonna. Yeah.
Okay. All right, so we made a transition into kind of a philosophical realm here, but we're going to talk about this because I think it can apply. I mean, we're talking about like let's say
we're talking about why does anything matter?
Well, let's say like SETI, okay? Like why fund SETI, right? What practical application could SETI possibly have, right? They're not finding anything, and it's been going on for 40 some years, right? So what's the benefit? I mean, how do you justify that? So we were just talking about justifying anything. We extrapolated it to art because we both love art and we're both artists. So, Gary is much better fine artist than I am, but
when you start asking the question about in science, is this research worth doing?
Yeah.
Then you start asking the question, is anything worth doing?
Is anything worth doing?
What's worth doing?
Yeah.
So, in my case, I would my direct thing that I have direct experience with is drawing or painting, and I was going to life drawing classes, which I really enjoy. And so you fill up sketchbooks full of these renderings of models on a stage, and I started to think, what's the point of doing this? Why?
You think too much.
I find it enjoyable.
Yes.
But it has no inherent value in and of itself. Nobody's really ever going to see any of this stuff that I've done. I could put it on social media, but let's pretend social media doesn't exist. Let's pretend it's 20 years ago. I'd be doing the same thing. I'd be going to these classes and I'd be drawing on a Sunday for my own enjoyment. So I wondered if other people felt the same way I did. So I actually found a book about people's experience going to life drawing classes. And I found there was a similar question. People, the author of this book said, why do we do it? And he spent probably a third of the book giving various ideas and theories as, what impulse does this satisfy? Why? So at the end of the day, what I realized is that, like anything in life, everything in life, if you enjoy it, you should be doing it, because that's the most you can ever hope for out of life. If you're not enjoying it, stop doing it. But if you dig it and you don't know why, and nobody else thinks anything of it and doesn't care about what you're doing, but you dig it, keep doing it. Because that's all there is. That's all there is, man.
You figured it out in your mid-50s. You figured out life.
Well, maybe. But
See, I have a practical explanation for, or justification for what you just said. Okay, so you said the philosophical part, which I completely agree with. I'm an epicure. If you put me on the list of like ancient philosophy, like I love Stoicism, I love reading about it, but I'm really more of an Epicurean when it comes to that, which is pretty much the Stoic philosophy, except I actively avoid unpleasant things. I don't believe that I need to have negative stimuli in my life in order to grow as a human being. I'm not saying that you can't. I'm just saying that I personally think that I can grow from positive stimuli as well. And so I seek out pleasurable activities. That's what I do. Now, I'm not a hedonist. Okay, that's different. But what I'm saying is that, on a very philosophical level, I believe that doing things that are good for me helps me be a better person, because if I'm in a good mood, then when I go to the grocery store and that checkout lady, she's like having trouble scanning that thing because that thing just won't scan, and and I'm like, then I'm in a much better position to say, it's okay, man, this stuff happens, don't worry about it, it's fine, and then not create ripples that would affect her day negatively and may cascade into something else. So, you know what I'm saying? So if it's good for my disposition to sit and meditate in the morning, or to go to the park and feed squirrels, or, or paint or write or do this or whatever it is that charges my batteries, it's not just good for me. It's good for whoever I come in contact with too. So it's not like this weird hippy dippy ripples in the universe kind of thing. Not that I'm saying that doesn't exist. What I'm saying is, on a very practical level, the people that I'm going to come in contact with, I'm going to be more pleasant towards, because I'm in a pleasant mood, right?
Yeah, that's not hippy dippy at all. And I've experienced the exact same thing. That when you're in your groove, you're doing the thing that is what you're supposed to be doing, the thing that creates no waves for you, the thing that is frictionless, that when you're doing it, you're like, this is what I should be doing. You relate better to other people. When you are in doing something in life that is just grinding your gears, it's the wrong thing, it perturbs you, then you're nasty to other people.
Yeah.
Without a doubt. So it destroys that harmony.
Let me tell you a little story about the other day, the donut story. Cool. So I walk into the shop and I know they've got the best donuts in the world, only on Friday mornings, thank God. So I walk in on Friday and I get one for, the sinker, which is like this giant, like cinnamon roll, and this, oh God, this donut that's filled with icing and has this big smear of icing on top. And it's, chocolate. Anyway, so I get it, and I'm taking home my beloved. And so as I'm checking out, this lady walks in a nurse's outfit, and she says something about, oh, she's like, oh, look at those donuts. They're packing up for me. She said, oh, but those things, they will get you, they will end your life, or I don't know, something like that. I said, yeah, you know what? Skydiving didn't get me. So I don't see myself going out this way. I don't think this is going to do it. So the skydiving will probably do it. She just kind of looked at me, and I was in the middle of taking my walk. So I was at the end. So I was all like, I was in a good mood. And I said, by the way, I said, all those like minutes, years, months, whatever it is that you like preserve by eating right and not indulging in this stuff, they're all at the end of your life when you're miserable anyway. So, why not enjoy it now? And she kind of looked at me, right? And because she's obviously in the healthcare industry, so this is counter thinking. And then, but the funny part is, I rang up the stuff. I tip. I get out of there. I'm leaving, and she says to the lady behind the counter, "What's this one filled with?" So I don't know if I made a sale for them or not, but live a little, live a little. One of those donuts isn't going to kill you, Like 15 of them a day will kill you possibly, or lead to complications. But have the donut.
Well, the old saying, in all things moderation.
Yeah, the other saying is moderation's for monks, but I think that was Robert Heinlein.
So that's my answer to why do anything?
I do anything. Well, that's what I'm saying. Like, why, so to get us back on track, why do SETI, right? So here's the other argument. We've only been doing this for 40 years. That's a drop in the bucket. We haven't had enough time to detect these civilizations, right? But that's not a real answer either, because according to Fermi's paradox, the way Fermi figured it out, they should be here, right? On this planet, contacting us. They shouldn't be out there. Like, if interstellar travel is easy and enough time has elapsed, they should be on the moon, right? They should be in orbit around us. They should be like.
Yeah, so it seems to me that Fermi's lunchtime discussion was predicated strictly on numbers.
Yes.
And from a numbers only perspective, they should be here. Yeah. But we've touched on a lot of the big filters.
A lot of practical filters, yeah.
Exist. And they're considerable.
And we haven't talked about all of them. I mean, there are many more, like gamma ray bursts, right?
The gamma ray burst thing was very interesting to me, because I was not aware of that particular phenomena.
Yeah.
And so for anybody who might be listening, the gamma ray burst is a thing that is not terribly uncommon out there in space. And if you have the misfortune of being, I forget how many light years we're talking about.
It's not that far. I mean, it's a pretty large range.
If you are within that range, it's a life extinguishing event.
You're gone.
Radius.
Pleasant. It's like the Lex. Do you remember the Lex? That's a really obscure, but it's like the giant dragonfly weapon. It bursts and the planet, not the planet's not gone, but all the biosphere is gone, right?
Right. So here's
planet would remain.
Yet another reason why civilizations that may have arisen are just extinguished.
Yeah. Yeah.
So I really found the number of filters really piling up, and these aren't extreme out there filters. These are really solid, credible ones that seem.
Yeah, these are the natural ones, like the ones that are like the ones that we predispose are like, because we talk about technology, we talk about the nanites and that sort of thing. There's another one that I just became aware of. I mean, well, that's not true. I've been aware of, but the last lecture I went to, we're talking about these rocket companies like SpaceX, Rocket Lab too, and a couple others. And they've been launching these swarms of rockets, right? They call them rocket swarms. They'll launch 30 rockets at a time, and satellites, right? For communications. They want to do it for cell phones and things like that. So, there's all these private companies that are launching it. Basically, from what I understand, and I don't know, but from what I understand, when you want to launch a rocket in the United States, you just call like this number in Washington. You say, hey, we're going to launch a rocket. Is that okay? And they basically go, Yeah, go ahead.
It's where you have to have the FAA is involved. There
Yeah,
have to be all kinds of plans, emergency
yeah,
plans, contingency plans, this,
yeah.
that, and the other thing.
But they
It,
rarely say no, is what I'm saying. Like,
oh yeah, I think they rarely say no. That's true.
so
So
what's happening though is all these satellites are being launched, and all this debris in the near Earth orbit, and it's making optical astronomy really hard. So like when you take long exposure pictures, you get these tracks where you never used to get this. Decades ago, you never got this, but you're taking like a long exposure of a star, and you've got like the camera panning from the ground, right, in an observatory, and all of a sudden there's only streaks on the exposure.
so,
And now you have to use a computer to get rid of those, and that's fine. But this is growing, and it's growing at an alarming rate, apparently, to optical astronomers anyway.
well,
Go
I just
ahead.
had a lengthy conversation with a mutual friend of ours who is
Mhm.
involved in a large, complex international astronomy effort,
I know who you're talking about.
and this topic came up because I was reading about the Starlink,
Yes, that's exactly what we're talking about.
and I follow certain people on Twitter, and every week it's like, well, another Falcon went up today, launching another 358 Starlink satellites, and I'm thinking, geez,
That's a lot.
how many are they going to launch? So I looked it up. Doesn't It's not very hard. The planned constellation size for the entire Starlink constellation, as they call it, 420,000 Starlink satellites. 420,000. So as of about 10 years ago, there were only 6,000 satellites in orbit.
Right.
Total.
Yeah.
420,000 they're going to put into orbit.
Yeah.
So naturally, there are two concerns that you've enumerated. One, the impact on astronomy, and two, the impact on space junk, because this is all low Earth orbit stuff that's in the zone of where the International Space Station is and where other satellites have to operate. So my problem with this is that yes, it is possible to subtract out that interference for astronomy purposes. However,
At the moment.
yes, but it also eliminates certain types of observations that will no longer be possible because of the brightness
Yeah.
of those satellites. You could subtract out, but some of these sensing methods require stacking, where you're looking at the same part of the sky over successive nights and you're putting them all together to get one complete image.
Yep.
Well, the satellite is repeatedly going over that spot, and it can outshine the thing the faint object you're trying to see, rendering your ground-based instrument useless for that study. So the impact is real, but also the space junk problem is real as well. Now, the FAA requires a certain degree of reliability in terms of deorbit technology. Most satellites that are launched have to carry onboard rockets to deorbit. They can't be left there as garbage. But the reliability rate, what they consider reliable, is 90%. So most of the time that's okay, but when you start talking about numbers like 420,000,
Yeah, so let's do a
10% of them fail.
back of the envelope thing here with Fermi would love us for this. So 46,000 or whatever it is, over 40,000 satellites going to fail, right?
So my problem with this is that this is the classic commerce versus capitalism.
Yeah.
Rather
Money,
commerce
money.
versus natural resources
Money,
debate.
money.
And the only difference now is that the frontier has changed. I don't think that you and so government organizations protect things like control of the airways, what portions of the RF spectrum remain available to us because they belong to all of us, and so forth.
Right.
National parks, oceans, you name it. The space above the Earth is exactly the same thing to me.
But there's no treaty.
I don't feel there's been any discussion about increasing the number of low Earth orbit satellites by 10,000%. I don't think that public discussion has ever taken place, and I just don't see how that could be allowed.
So it's my understanding that some optical astronomers have expressed some concerns and written some people who are in charge of corporations that have done this. One person in particular, and the reply was basically, "Oh, we'll build you an observatory on the dark side of the moon."
Yeah, right.
So is that flippant? Like, you know what? We don't. Basically, you don't count. I
So
have money.
I'm in
You
favor. The
don't
whole
count.
reason to build these constellations in orbit is ostensibly to provide communications, internet access to remote regions.
Yeah.
That's cool. I'm all for that, but there has to be a
At what
risk benefit.
cost?
There has to be a risk benefit analysis.
Yeah.
Yeah,
At what cost? Right.
and I'm not seeing enough public debate about this, and it bothers me.
So here's the other thing that happened too, which I was dimly aware of, but I didn't understand the effect, the full effect that it had. I guess in November of 2022, the Russians destroyed one of their own satellites.
Yes, this was a
just
big
to
deal.
see what would happen.
What would happen? Yeah.
So basically,
a huge cloud of debris.
yeah. So basically, instead of one defunct object, there's now like tens of thousands of pieces of this defunct object. And so apparently, like even the members of the International Space Station had to take cover for a second, or like whatever. But like it's it's just amazing.
Arrogant. It was extraordinary arrogance to do such a thing.
Say we can do this, so we will do this, and it just speaks to me again of the possibility, even though again it's anthropic, but like the or it's not anthropic, it's human centric. That all it takes is a couple individuals to ruin the party, right?
Sure.
So, you can make a treaty saying like, we're not going to talk to those guys over there, but all it takes is one drunken alien to go, I'm going to drive over there anyway,
And again, if you're talking about numbers, that's part of the numbers argument. That
Right.
if 99% of your species is controlled and ethical,
Yeah.
That still leaves the radicalized 1% that have the power to be incredibly destructive.
Yeah.
Well, let me bring this back to one more. I think I only have one more slide that I thought was notable here.
Oh, good.
And that was that his position that life is common, but intelligent life is not.
It's common but stupid.
So biologists tend to agree that other forms of life likely exist. The number of planets on which life might start is large, obviously. But they don't buy the deterministic argument that high intelligence evolved on Earth, so it must eventually evolve on other planets. They tend to see the implausibility rather than the inevitability of intelligence. So the galaxies could be teeming with organisms, alive, reproducing, none of which are tool makers or self-aware or conscious.
Well, what's the advantage of intelligence from an evolutionary standpoint?
The advantage?
Yeah.
The advantage is that it's more likely that you can survive adverse conditions in order to procreate.
So again, what if you have a world that's really nice and there's a lot of symbiosis and you have lichens, and you have these interacting creatures that depend upon each other. And if I can imagine a world like that, right. I'm not saying but like, why couldn't that exist? And so since there's little competition, if any, for resources, maybe everybody's got their own little biome and they have their little fun in that little biome, and there's no crossover, so there's no competition. Or
have you ever read the book Guns, Germs, and Steel?
Yes, of course.
Okay, so yeah, everybody had to read this about 15, 20 years ago, whenever it came out.
But we should probably read that one again and do that one.
And yeah, I enjoyed that book. He wrote two subsequent ones that weren't quite as good, but were still interesting. One of them was called Collapse.
I remember it. I didn't read it, but I remember it.
Why great civilizations fall apart, the Mayans and so forth.
Yeah.
But in Guns, Germs, and Steel would argue that, well, why did Northern or European cultures become scientifically advanced and other parts of the world did not? And there are many factors.
Talk about the Dryas, right?
What's that?
The Dryas, the younger Dryas.
The younger what?
Oh, the Dryas, Dryas. So there was a period called the Younger Dryas where there was ice and in Northern Europe and in most of Europe, I think. And there was it was a cold spell. And so, the humans that lived in that part had to harden up, they had to like invent things that they
Right.
didn't
So
need before.
getting back to your question about, well, what if the living is easy? So
Yeah.
that incentive,
Yeah, you live in the tropics, you live in Hawaii. It's 72 degrees with a nice breeze most of the time. I was
right?
talking to a guy today who lived in Hawaii, he was stationed there in the military back in the day. He didn't have a heater, he didn't have a furnace, he didn't have an air conditioner. He had louvers and he could open them up, get the trade winds to come in or close them down. And that's it. That's
So
all the
maybe
temperature regulation he needed.
if you're a life form that is living on a planet where the living is easy, there's no biological or evolutionary imperative to develop further because
Stagnation,
things are good. Yeah, you're stagnant.
technological stagnation.
Right.
Yeah.
Right.
Maybe your culture flourishes, but there's no reason to develop technology because there are no problems to solve. Everything's great.
Exactly. And the whole reason that Western civilization really developed was we cultivated wheat. And once we cultivated wheat, it allowed us to settle down and live in one place and cease a nomadic existence. And once you've done that, then you're no longer spending all of your waking hours searching out for food. Now you have time to think about other stuff.
And there's specialists who can like
Specialists, and
make
also, of course,
pottery because they need to
Europeans
store
were
stuff and they can
Europeans were
build
blessed
things.
with domesticated animals.
Suddenly you
And
have
other parts of the
pyramids.
country really didn't have useful domesticated animals, or they had useful animals, but they couldn't be domesticated and harnessed for work of any kind.
Yes, yes, that was interesting. See, that I found very fascinating. It was like, okay, or they didn't have enough. Here's the one that was really interesting. They didn't have enough calories, right? So his example was Papua New Guinea, right? So in Papua New Guinea, the terrain is terrible. There aren't any there aren't any beasts of burden that you can use. And
Right.
the highest calorie food was this kind of root, taro root, I guess. And you couldn't cultivate land. It just was not arable land. Like the soil was terrible, the erosion was terrible. If you cut down the forest, it all goes ran away. So like you pretty much couldn't advance beyond a certain technological level readily because of those three factors. And I thought that never entered my head. I would have never come up with that theory. What an interesting theory.
Yeah, it all fit together very neatly in a package to kind of explain, why this culture here and not there. It's just random factors associated with the climate.
I think you could go
And with
further than that, and you could talk about culture as well. You could talk about philosophy and culture because the Greeks, right, had kind of this dual. We still suffer from it, I think, at times. It's a dualistic approach towards everything. There's good and bad. There's male and female. There's up and down. There's it's everything is one or the other, right? It's a bipolar kind of. It's not even a continuum. It's usually it's like an on and off kind of thinking, and that kind of thinking is simplistic, but it's not terribly useful in some ways, but it this us versus them kind of thing. Whereas you could argue that like there are cultures in the Far East that it's more of a holistic kind of thought where it's like, well, it's all part of a whole, and so that leads to like, well, since everything's part of the whole, why change anything? Like it's all the way it's supposed to be. So like, why change anything?
This puts me in mind of the arguments for saving languages that are about to go extinct.
Right.
Because when you learn other languages, even very common languages, Spanish, Italian, um, that for instance, how other Romance languages have gender assignments to common objects. Bridge is female in one call in Spanish, I think, but it's male in German. and the way that people write sentences about bridges, uh, or how they describe bridges, is influenced by the gender that the object has in that language.
Wow. That's
Well,
deep.
I recently heard something about this. It was that's a really simple example, but you know what I'm talking. You've heard much more interesting ones, I'm sure, about how the reason that the loss of obscure languages is so devastating is that different languages formalize different conceptions of reality. That it's hard to understand them um, through some other lens. But when you really dig into the language, the language has developed around this worldview that other cultures have. That through the language you can parse that worldview, and some of these concepts are extremely alien to us, and yet if we had the time to understand them, they're extremely enlightening because it's an alternate way of apprehending what we all experience. But we get very enmeshed in, well, it's objective reality. We all experience the same way, right? But we don't. If that were true, all languages would be the same. But that's not what we find.
Yeah.
That kind of fascinates me.
And to go with the germs, guns, and steel thing, it's where, the terrain, the climate, the locality of those places, and the fact that we didn't have instantaneous international travel or transcontinental travel, these pockets of, culture and language and other ways of doing things existed is in pre-technological times, especially, but they even into like, until maybe like the Roman era, where like there's some continuity because of road system and things of that nature. But what you were saying about language is interesting, because there's a computer game I play called Fallout New Vegas I love, and I just recently started playing with the language settings, in particular because this one character said, "Loose lips sink ships," and I thought, I wonder what they say in French, right? So I loaded the game in French. Well, I can't remember. That's terrible because okay, Italian. I loaded it in Italian. I can't remember the French right now. And it was because loose lips sink ships comes from World War I, right? That comes from like a very specific historical phrase. It was I remember posters with that on there, and they'd have a liner being sunk, by a U-boat kind of thing. So I said, that can't be universal. So, and it's not. So in Spanish, it was something about lingua and spada. So it was like you can kill more with the tongue than the sword. That was how that idiom was translated.
Yeah, yeah.
And then in Spanish, it was a closed mouth gathers no flies.
Mm-hmm. Mm-hmm.
And then in German, it was silver is nice, but gold is better. Mm-hmm. Or no, silence is silver. Wait, it was speaking is silver.
Silence is gold.
Silence is golden is what it was. That's what it was. And then I forget what the French was, but it was fascinating that like somebody somewhere had to translate that. Somebody somewhere had to like say, wait a minute, that's an English idiom. Well, we need this character to say something. What are they going to say? So somebody had to make that determination. I always find it fascinating, especially with poetry. When people translate poetry and it rhymed in French or Italian and it rhymes in English. How does that happen? That doesn't happen because it's not easy to rhyme in English. It's really easy to rhyme in Italian.
That gets to the whole thing about how problematic translation is.
Yeah.
I remember maybe a year or two ago, and I've never read it. It's not the kind of book I would ever read. A new translation of War and Peace came out. And people who are expert in such things were raving about, oh, this is the closest you're ever going to get to the original Russian.
Nice.
It's the same thing that we're talking about, that there is a feeling and a way of expressing ideas in one language that just cannot be directly translated. You can put the words in. You can substitute the word for dog in English for a dog in French and other objects. But feeling and emotion, they are not nearly so easily translatable.
Yeah.
There's a lot of the je ne sais quoi, the ineffable about language that gets back to that idea of how a culture conceptualizes reality.
Oh, and even within our own culture, I mean, well, we're a large country, so there's so many subcultures. But even with the advent of, you know, the interwebs, just finding your like, I can't even go on Reddit because I can't figure out the rules to all these subreddits, right? I mean, like, what am I allowed to post and not get kicked off? Or like, you know what I mean? Like, I just don't like, I don't get it. Like, there are all these like little cultures. So like, YouTube, I get, right? I understand the community, but I've been here since 2016. So like, but like Twitter, I am at a loss. Uh, Facebook, I still feel like a bumbling adolescent, socially on Facebook. I really don't know how to use that platform. And Instagram, I'm an infant. But like, like I just don't, I don't, there's so many to choose from. And within those, even if I know how to use the platform, there are all these little subdivisions. Like on Facebook, I have I think I created 3 different Facebook groups. And so, but I post different things to each one because it's a different audience, right? So like the joke that I tell about Star Wars can go on the one, and the joke that I, or the wonderful piece of art that I took a picture of at the gallery, I post on a different one, right? So, it's dynamic, and it's and there's so, like you said, there's so much out there, so much information out there that, like, why wouldn't an alien species just stay at home and explore their own cultures or invent new ones as we are,
Yeah. So at the end of the day,
or just look at cat videos,
to kind of to kind of wrap up the discussion on the book, uh, it there are so many there's so many filters for extraterrestrial contact, or even the development of extraterrestrial civilizations, that even given the sheer numbers of planets out there, it still seems very explainable to me that we don't see evidence around us and that we're not being contacted by. So it doesn't seem like that much of a paradox at all when you really get into all the reasons why we should expect not to be contacted or be aware of others.
I think we're alone out here.
That's one of the most interesting theories,
I think
and
that's
that
why I'm person.
he doesn't really spend much time on it.
No,
Yeah, the idea that it's just us.
just us.
There are no other civilizations.
I'm not saying that there never were or there never will be, but I'm just thinking like the distances are vast. The timing is bad. The window of like communicability between that and either transfiguration or destruction is relatively narrow when it comes to cosmic timelines.
I think that window is really small.
I think it's really small. Yeah, I think it's like, I mean, think about the last 10,000 years, like that's really when human beings really came into their own, right? You're talking about domesticating wheat. When did that happen? 6,000 years ago? 8,000? I don't know.
Probably something on that order.
I think it's less than 10. So,
But you're getting into the thing that people often use when talking about the immense timescales of the universe, which is the cosmic calendar, right?
Yeah, that's a really
learned about
handy.
That when I was,
that's very handy, actually.
I learned about that when I was 13 from, again, that famous show that we both watched.
Yeah, and I think that helps to conceptualize it, because like when we talk about I love this one. So when we talk about millions and billions, so like when people talk about money, they talk about the budget or they talk about spending, and they talk about GDP, millions. So a million seconds is like, I don't know, from now until sometime next week, right? It's something like that. But a billion, right? We just change a letter, so it doesn't sound like a big difference. A billion is like 32 years. Okay. That's a long freaking time compared to next week, right? So when people hear like, and we throw around that number now, billions.
Well, yes, we do, and I don't want to ruin this conversation with politics, but frequently we talk a lot about national debts and deficits, and we talk about 14 trillion, 20 trillion dollars in debt that we have to pay off. None of the politicians who are throwing these numbers out have any conception of what this
It's
means.
like having a conception of the size of space.
It's exactly the same. No one can conceive of how much money that is. The only way to quantify it is to talk about, well, if I paid X number of dollars for the next X number of years, how many years would it be to pay that off?
Exactly.
That's the only way you can conceptualize it.
It's the only way to do
That
it.
is
So the cosmic calendar works in that
Yeah.
way. So you say like human beings showed up, what, like 3 days before the end of the year or something like that?
Not even.
2.5 or 1.5, something like that. It's small. Like it depends on what you
the
mean.
last day.
It depends on what you mean by human beings, right? So it's what do you define as human, right? So
Recognizable Homo sapiens.
Hominids, or is it Homo sapiens sapiens, or is it technological humans? And if you're talking about technological humans, Stephen Webb talks about maybe 300 years. Science, he talks about, right? So he's talking about like maybe 300 years. So we're talking minutes to midnight on the 31st of December, right?
Seconds.
Is it seconds?
I think so.
It may be. So it's like, it's really, we haven't been around long enough for anybody to detect us. And unless they're just hanging out in the solar system, like these von Neumann probes. But like, is it, well, that's the other one that was interesting. Maybe the probes turn on them, right? So like you get a V'ger kind of event from like Star Trek 1, the worst Star Trek movie ever. And like, you just like something happens, it gets irradiated, some other programming gets like, it bumps into something and then it turns around and goes, kill all humans, and it turns home and it like eradicates the host civilization. But I don't know. There's a lot of really great ideas in this book. There's some iffy science in this book.
Yeah, so
there's some good science too, though.
So I'm reading the 75 solution version compared to the 50 solution.
Yeah, tell me some of the more exotic ones if you think of any.
I would have to actually look at the table.
Oh, never mind then.
But what I was going to say was that I thought the book could have been cut in half. It would have delivered the same message. There was a lot of time wasted. He went into extraordinary detail about DNA and protein and things like that were just, I can take it as read that these things exist. I didn't know. It felt like he was padding the book out.
Yeah.
Why he would go into extraordinary detail about things like that, but not about the inner workings of the atom, which are just as critical for the scientific arguments that are being made for other chapters in the book. Didn't go into those, but he went way into biology.
And some of his solutions aren't really solutions. He's like, sometimes he's just talking about biology in general, and he's not telling me why it solves the problem. He just says, oh, well, this is how hard it is to make biology. Oh, yeah. Great.
So I mean, it's
related to like the problem, right? So again, like for me, like the phosphorus thing was one. The other one, there was another ingredient to life that was like exceedingly rare. Oh, I know what it was. It was something that allowed amino acids, some kind of like, it was a more complex chemical. It wasn't an element. And it was, I can't remember what it was now, but it was something that allowed catalysts, to happen. It was a catalyst. It was something that allowed cells to divide, or either meiosis or mitosis or something like that. And again, I'm not a biologist, obviously, but it was another filter that was like, this ingredient is so rare that, right? So would you put in the chat?
Oh, not to take away from your discussion.
No, please.
But so I'm not a science fiction consumer in books. I tend to read stuff about ordinary folks facing ordinary problems of family conflict and such. But one of the few science fiction books I have read is called Calculating God, and it has everything to do about the things that we're talking about here.
Oh, cool.
And the premise, and I think you would really be interested in it. The premise is that we are contacted by aliens, and they're all about mathematics, and it is the premise allows for this exploration of things like the fine tuning of these various physical constants. That was actually my first exposure to those discussions. So
So,
if you want to have a fun science fiction leap or exploration into the universe appearing to be tuned just for us,
yeah.
it's a good book for that.
Well, what would you even say to, like, okay, so you meet, so let's say we meet an advanced civilization that's on the number two level of the
Yeah,
Kardashev.
we would have nothing in common.
What would we say? What would you say personally? Like, what would I say to someone
Right.
like that?
There would probably be very little meaningful that we
Probably
could.
say, glad you're there. Please leave me alone.
Right. So I mean that's kind of a joke that's made in the book, the one we just read, that you really would hope that you don't encounter another alien civilization, because the likelihood that we'll be at the same uh, technological development stage is zero. Well, obviously not, because they've got here across the vast reaches of space, so they obviously have technology far beyond our own. And that being the case, it would be like encountering cavemen. Well, there would be nothing to talk about. There would only be we would be observed,
Yeah.
as a curiosity, but not a civilization with whom you would want to exchange
Well,
thoughts.
that's what
They're
Hawking
inferior.
said on numerous occasions. Said just keep your head low, like don't like be transmitting stuff. And
Right, and he talks
fortunately,
about this in the book, that isn't this irresponsible
yeah,
for people who are heading some of these SETI programs to be
just do
transmitting
it.
a high-powered signal that says, "Here we are." That could be the worst thing imaginable.
Yeah. Fortunately, apparently they sent it to a cluster that like there's pretty low risk of anything being there. It's like the something to do with the galactic cluster having like radiation, too much radiation. Like it was a type of galaxy. It wasn't a spiral arm galaxy, but like a lot of like elliptical galaxies, which they think would not have Goldilocks zones. So the type of life that would exist there wouldn't be. But here's the other thing. We talk about evolution. We talked about, stresses. So like if there is a really rough and ready like civilization that lives with heavy radiation, like we probably don't want to mess with those guys. You know what I mean? Like they're pretty tough, I'll bet. And that they're and maybe that solves the spacefaring problem, right?
Maybe they're loving. Maybe they're loving and benevolent.
Yeah, maybe they know what love is. We could only hope.
So I think
Good place.
at the end of all of it, I don't think the Fermi paradox is all that paradoxical after all.
I love that. That's a
There are
wonderful way to conclude this.
yeah, lots of practical explanations as to why we don't hear from anybody else.
Well, and don't want to.
Don't want to, yeah.
Yeah.
Well, I think we do want to, because we're human, because
We don't want to be alone.
it's an unanswerable question, because it's a question that anybody who's ever looked into the sky at night, everyone's wondered it. You think, is there some not person, some intelligence out there looking at the sky right now, thinking the same question?
Yeah.
Does somebody live out there?
Yeah. It's a poetic notion. It's
Well, not to mention, here's a problem though. It could be cataclysmic for human culture, because it would end our feeling of being special, and it would upend religion. That's a whole other topic, right?
I guess, but yeah, that's another topic. I've
Because then you would have to
I've
account for.
actually heard some like people who have chosen to speak on behalf of their religion talk about this. it's interesting. But maybe we can find a source to read about that and then discuss that.
Well, so they're probably out there, but the thing that occurs to me about that is that if you are a religious person, you would then have to account for you would have to come up for reasons why the supreme being who has revealed all these other truths to you chose to keep that secret
Oh, that's a mystery.
or lie.
It's a mystery. Whenever something can't be explained, it's it's like that cartoon. There's a scientist at a board and he's drawing equations. And step A, blah 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 blah. He has this very long.
Miracle happens.
A miracle happens. Well, maybe you want to elaborate about that. Maybe you want to elaborate about step B, where the miracle happened. But it's I don't know. Are we at the end of science?
I think so. I think I've gone through all of my points that I thought were worth talking about.
Yeah, we've done this a good service, I think, and thank you, Stephen Webb, for writing this book, and thanks everybody who stayed and listened, and got merch, and it's in the background here, and it's not scientific, it's philosophical. You have questions about that? Ask me. There's links. You can buy a hat. We passed 11,000 subscribers. Just not long ago. So this thing's starting to gain some traction. So pretty happy about that. And hope you enjoyed it. If you have any comments, put them in the appropriate spot. I like to answer all the comments that I get if they're nice. Be
nice.
And I don't understand a lot of these emojis. So you could probably insult me through emojis. I wouldn't even know. All right. So we'll let you know when we're ready for the next one. Gern Blanston, thank you so much. Always a pleasure.
Thank you, Patrick.
Signing off for now. The WOW signal.